we provided them this information. We told them, hey, these are the process parameters you need to use for achieving 8 years run length. As I said, we redesigned their transfer line to lower the temperature and further. We also looked at waste heat recovery, but they finally went in for air preheater on this heater. So what did we do? We did just provided simple features, and these are some of the salient features I'm trying to show you. Average radiant heat flux, we used 10,000 BTUs. We used a 5-inch coil, nested coil. We used 66 foot of tube length to get a heater height to width to length ratio of 1:2:5. And we put burners every 3 to 4 feet. So that is all. And if you see, all these recommendations are very simple recommendations, nothing out of the ordinary, but it's a combination of all these parameters to get run length. By the client for this reliable design was about 10%. The client also went for 2 single cell heaters and combined them with a common air feed system. The logic was that if they have to ever decoke their heater, I mean, they never had to decoke it, but if they have to decoke one heater, they can always do that independently. So they went in for 2 heaters and with a common air feeding system, which was, and this is the basic sketch. So I want to show you 2 comparisons. I want to show you first the design which was put up in that first refinery, and that heater happened to have the same size, and it was recommended, developed by the licensor. This heater had 12,000 flux, a mass velocity of 282, coil size of 6-inch, and other parameters I have listed, heat release per burner. And we calculate a coking index of 30 over here. And if you look at our design, it is not very different. It's just a cabin. We used 10,000 flux. We used a mass velocity of 357, coil size of 5. We used 5 million BTUs burner. And our coking index is coming out to be 8.7. So if you look at this thing, our heater is about 3.5 times more reliable than the design given by the licensor. And if you look at the cost, we are talking about just 10. I mean, I have given you the breakup over here that we are looking at only about 10% or 15% more cost. So what will you spend 10% more to buy 3 times more reliability and run length? That's the question you need to pose. So basically, that's where the biggest difference is. And I think a reliable heater will go for you for a long this thing. We are coming to close, so I just want to talk about one case over here. So this is a heater, crude heater again with 200 million BTUs heat duty. The client shifted to shale crudes and started experiencing very short run lengths. They started injecting antifoulants, costing millions of dollars every year. The client contacted us and asked for our help. We did an engineering study, and we looked at the operating data and told him that the upper 1/3 of the heater, which you see over here in yellow, was receiving 40% of the total heat, and bottom heat was receiving only 25% of the total heat. So there was a heat distribution mismatch in this heater. And the situation was so bad that they were decoking it every 3 months. And they were also putting antifoulant, which was costing them millions of dollars per year. So we looked at it and we said, we can help you. We can work with you. So we gave them a lot of recommendations, again, both on the coil side and fire side. Fire side, we said, hey, we will put small burners instead of a large burner. So we ended up putting small burners, ultra low NOx burners with reduced flame length. It reduced the tube metal temperatures, and it improved the run length by 8 times. That means from 3 months, we went to 2 years. Now, we could have gone for more if they would have implemented our coil side recommendations, but the coil side recommendations were not implemented because they had only retubed the heater last 1 year. So they said the coil is still new, so we will do it in future. So, but that's what I want to show you over here. You can see that we did the CFD modeling. This is before and this is afterwards. And you can see by having shorter, narrow flames, we were able to improve the heat duty. And if you look at the coking index, we just did the comparison of coking index, and you will see the process parameters have not changed because we did not do any process modifications. We only changed the heat release per burner from 38 to 13, improved the burner side pressure drop, and by doing these changes, we were able to reduce the coking rate by a factor of 3. Now, our calculation is showing a factor of 3, but actually it was a factor of 8. So you can see some of these modifications can really improve the run length, the simple modifications. And we want to ask you that if you have any crude heater that is having a run length issue, we can help you there. These are some of the references we have done crude heater jobs. I do want to have another poll, if you can let me do that. So a question is, what is the typical run length of your crude heater? So if you can answer back, that will be very nice. We can get a little better idea of the run length. So please answer if it is less than 2 years, if it is between 2 to 3 years, between 3 to 5 years, So please get back and I will share the results with you of this poll. So 50% people have voted. We still have a little bit more than 50 seconds to go. Please submit your response. So I'm closing the polls, and the results are that 33% of the audience has run length between 2 to 3 years, and they are definitely a candidate for improving the run length. 44% have between 3 to 5 years. We can improve the run length there. 22% have more than 5 years. I think they're running their heater very nice. So thank you very much. I will go to questions now. And if you have any questions, please. So I have a question from John Roberts. With the increase in crude feed rate, what will be the coking index proportionately rising? John, good question. Now, when you increase the crude feed rate, the mass velocity goes up. So it does have a good effect. But at the same time, the flux also goes up. So, and the firing rate will go up. So if you increase the crude feed rate, the coking index will go up. Assuming I'm saying with the increase in crude feed rate, your firing rate is also going to go up. I mean, if you are going to be reducing the outlet temperature and keeping the heat duty same, then definitely the coking rate will go down. Any other questions we have? Well, thank you very much for giving me a patient hearing. I thank you all for attending the webinar, and if you have any issues or if you have any suggestions, please let us know for our future webinars. And if you have any issues with your crude heaters, we are always there to help you out. Thank you. Thank you all. I'm ending the webinar now.